This is the third part of implicit differentiation, starting on Stewart, chapter 3, section 5. The last example, this is on page 211. X to the fourth plus y to the fourth equals 16. I want to find y double prime, or the second derivative. Now, one of the questions is that this is somewhat of a labor algebra intensive problem. So I'm going to go a little bit slow on this one just to help you out a little bit. What's the first thing we do? We want to take the derivative with respect to x again. The derivative of x to the fourth is 4x cubed times dx over dx plus the derivative of y to the fourth is 4y cubed using the power rule. Bring it on down, subtract 1, that becomes 4y cubed times y prime, and the derivative of a constant is going to be just 0. I'm going to solve for y prime, move everything over, move the minus, I'm going to take this out, subtract 4x cubed, and erase this one right over here. And then what I'm going to do is divide it by 4y cubed. That gets rid of this factor right there, 4y cubed. And so you end up with y prime is equal to, clean that up for me, negative x cubed over y cubed. And all I have to do is take the double derivative now. This is where it gets a little bit intensive. We're going to take the derivative with respect to x again on the left side, d over dx. And the derivative of y prime is y double prime. Easy, right? And so we take the derivative with respect to x of, I'm going to factor out a negative in front. Always factor out constants or coefficients and negative as well. You're going to get x cubed over y cubed. Oh, it's a quotient, right? X cubed over y cubed is a quotient. You have to use the quotient rule. Y double prime is equal to low y cubed times d high, which is 3x squared, minus high, which is x cubed, times d low. The derivative of a low is going to be 3y squared times y prime. 3y squared, there it is right there, times y prime. All over low, which is y cubed squared. I'm just going to go y to the 6 right over here. Okay, so it'll be easier. We do have to substitute y prime though, because I know y prime is this right over here. This is where it gets a little bit tricky. So I'm going to write over here, y double prime is equal to, let's rewrite this, 3x squared y cubed minus 3x cubed times, I'm going to factor out the 3 in the front, 3x cubed y squared times y prime is going to be negative x cubed over y cubed, all over y to the 6. Got a little bit of an issue right there. That's because of the fact that we have a complex fraction. Let's clean this up a little bit. Let's see what we get. That's equal to y double prime, right? 3x squared y cubed minus 3x cubed y squared. One of the y is going to cancel. So I end up with x squared. Oh, a negative and a negative is going to be positive. And you end up with 3x cubed y, cancel with one, two of them over here, x cubed over y, all over y to the 6. Now, since you have two terms in the numerator over y, I'm going to bust that fraction. What I'm going to do is multiply it by the common denominator, which is just y over y. Let's distribute the y to the first term. You end up with just 3 x squared y to the fourth. You have 1y times y, with y to the third times y is y to the fourth, plus we factor out, take out 3, x cubed y, in fact, we can do is x cubed and x cubed, it's just x to the 6 right there. All over y to the 7th. Y to the 6 times y is going to be y to the 7th. You see why the y cancel with this? You end up with just 3x to the 6th. And the first term, multiplying by y, you end up with 3x squared y to the 4th. We're going to factor out, we got some information here that's going to help you out. You can factor out 3 in the numerator. You can also factor out x squared. What do you have left? You have y to the 4th plus, we factor out 3, we factor out 2x squared. So you end up with x to the 4th all over y to the 7th. But here's a little trick that you have to remember. X squared plus y squared was 16 at the very beginning, right? So x squared plus y squared, that's equal to 16. That's the little tricky part. Notice a lot of algebraic manipulations right over there. You end up with the final answer as y double prime is equal to 3x squared times 16. 16 times 3 is 48, all over y to the 7th. 48 x squared over y to the 7th. A little bit tricky of the algebra that's involved, especially if you're dealing with complex fractions. Make sure you simplify that into a simple fraction. Good luck, and I'll see you on the next section.